Thank you very much. So yeah, I'm glad that I'm here and that I've been invited to give a little presentation. My name is Markus Obermeier. I'm working for Siemens in the field of additive manufacturing for quite a while now. I mean, I probably do not have to introduce Siemens itself, but maybe a few figures what Siemens is doing in additive manufacturing. As you might have realized, our booth is not filled with 3D printers, so we're not manufacturing those, but we are working together with companies like CEAD to industrialize the technology, equipping printers with industrial automation equipment, with controllers, with drives, but also on the software side, delivering the right solutions for making this technology a mature technology used in manufacturing processes. So we consider ourselves to be one of the largest software companies globally. So we have been investing hardly in acquisition of different software companies in the past years. So you just see 14 billion in investments in the last 14 years. So this is where the company is really heading to become an enabler for digitalization. So myself, I am responsible for multi-axis technologies, especially the extrusion technologies within Siemens. And I got a new role, a very exciting one. Earlier this year, I'm responsible for building up and managing Siemens Additive Manufacturing Hub in Munich. And I can tell you, Munich is a very nice place to drive this topic forward. There are a lot of innovative companies, and there are a lot of Flexbot that's installed as well now. So yeah, and it's where I am located. You can see behind me there are the other AM hubs. Our, let's say, major AM hub is based in Erlangen, where we also have a Flexbot installed since a couple of years now, starting in 2019 after Formnext. And we have another AM hub in Charlotte, North Carolina. The manager of that hub is Tim Bell. He's also over there in our booth. And if you want to reach out to our US colleagues, you have the chance here. We have another one in Nanjing, China, one in Singapore, and last but not least in Berlin, which a colleague of mine just is also starting to build up. Basically, the role as a hub manager is to, let's say, leverage the ecosystem effects. So local companies collaborating, working close to each other in order to develop projects jointly on with let's say, a little barriers. That's what we try to do. Yeah, I'm also excited that the large-scale extrusion is definitely a huge portion of that area. Now let me jump into the Erlangen hub, because this is where I spent my last years, and this is where we actually also have an AM Flexbot System installed. So AMEC stands for Additive Manufacturing Experience Center. This is our, let's say, a core competence center when it comes to industrial additive manufacturing. It is in a factory site, in our electronics production site in Erlangen. Basically you can see the picture of the AM Flexbot system which we have installed here. It's a similar one to this one. It's a slightly different robot type. It's the Kumau NJ130, so a little shorter arm but a little more payload. We use it for printing and for machining, so it has a milling head, a milling spindle, and a print head. And basically, we installed that system right after we showed it on Formnext in 2019 when we had the Flexbot system on the Siemens booth. Ever since then, we have been using the system to develop some in-house applications. I brought two applications. Internal and external ones at the end of the presentation, but we also use it a lot to discuss how to further develop technology, how to show it to end customers, to make them aware of what is already possible, because we have a lot of customers in the automotive industry, in the aerospace industry, in different industries, and many of them are not fully aware of the capabilities of large-scale additive manufacturing yet, and I think this is to create this transparency and to bring a lot of people in and show them what can actually be printed is a huge value. But today, here you have also a short visual impression how this looks like in our Erlangen facilities. So this is basically a video from that one. Actually, we are very excited because we will move into a new building soon, and we will get, like the Flexbot will get an even bigger and better appearance there. We will be included in a huge digitalization application center, and very much looking forward to that. It will be released will be opened in June. So if you plan to spend a trip to Erlangen, make sure after June is the right time to visit us here, because there's a lot to explore. Even though if you have already seen the AMEC, there is like the new version very soon. So, as I said, I'm exploring myself that many companies now are realizing the capabilities of large-scale additive manufacturing. They are leveraging the possibilities and start playing around with it. And what is, in my point of view, very important for the acceptance and the success of the technology is what we as Siemens typically call the fully integrated process chain. To speed up the iterative engineering. And what we mean by that is that you basically, let's say when you design a part, when you design it for 3D printing, you might want to get some very fast feedback about the printability of the part. When you then have finished your design and you start slicing it, preparing it for the printer, maybe want to start printing or already have started printing, and then like your colleague comes up with a new idea how to change the design, or you need numerous versions of the design, to not have to do the process workflow all over again, but to have that in an integrated workflow where you can jump back and forth and make adoptions. That is what I consider a fully integrated process chain. And I think with that system like we have it here, it is already accomplished quite good and can be achieved very nice. I just want to give you a few examples. So one, from a Siemens perspective, there is one very crucial element. So you can drive a system like that with our software, with the Siemens NX CAM. So there is a specific machine kit which is also developed by CEAD for our NX CAM solution, and it's then integrated in this huge, massive CAD CAM environment from which you can, let's say, program and your robot, but you can also design and simulate your parts. So in general, the software solution or the digital change starts, first of all, selection of the right technology. So you can see some of them which are possible with that kind of specific software solution. So just imagine you have a Flexbot, or maybe next to it you have a DD machine or something, and you want to, let's say, use the same workflow for both of them. That wouldn't be a problem here, because you can just use the same approach, just select different nozzles, different print heads. I think it's a huge value to be able to select what kind of machine you want to print this on. Also, if you might have a CFM Prime on the one hand side and then the Flexbot on the other side, it is possible to have different kinematics and different printer systems to get started. So the workflow basically looks a little bit like that. You have your component which you design, which you also might want to simulate, like if you want to have it optimized for fluid simulation, for example, or airflow, or whatever, you can do that. But then you want to get the first feedback about the printability, and then iteratively, let's say, going through the process chain from slicing the part, simulating it, until you actually simulate your machine. So I do not need to talk about CAD systems. I think everybody knows that, but that is the base of everything where it starts. You design your part in a CAD system, and different to many, let's say, other solutions where you, let's say, are very specifically dedicated to prepare for 3D printing. Here you already have a CAD solution involved, so you do not need to export and import into a print preparation software. It's like one continuous workflow. then that is what I meant with feedback about printability. So in this case, you have just a simple design for additive manufacturing checker where you can see what the overhang angles are, and if they exceed a certain level, which you probably would need support structure or you need to reorient your part, you would see that right away here with just a few clicks. Then the print preparation also comes with part splitting a part, decomposing it. So just imagine if you have a part and you want to print on it from multiple directions, you first of all need to decompose the part in those areas. So you can maybe print the purple color first, and then you reorient it, and then you print maybe the silverish bluish one on that one. And just one thing, if you see the purple shape on the outside and you see the yellow one on the inside, you realize that it would be like the same printing approach with two different materials maybe, or two different strategies. There's a very powerful command in the software solution called merge, where you can merge basically different nozzles, different parameters in one print set, and the machine basically switches then within one layer. Of course, it's time-wise a quite huge effort because just imagine the Flexbot would need to change the print heads, but it is possible, and it might make sense because you cannot print the yellow one after you printed the purple one, or vice versa. So you need to print them in one go. And then, like simulating the position process, the build-up to see if everything is programmed right. The blue surfaces are already finished. So some Flexbots are equipped with a machining head, so with a milling spindle, where you can also machine the part afterwards. And that is, of course, since you're already in a CAM environment, no problem. So you can machine the surfaces quite easily. Here you have an overview of few of the build-up strategies which are available. It's just the next stretch, and there are way more available. And CEAD made very customized ones which allow you to slice in 45 degrees, to print the raft, and stuff like that. And then last but not least, it's very important always to simulate your machine to see if there are any collisions, if the robot can reach each and every position, and so on. So this is like the workflow, I think quite straightforward, but it only makes sense, or it provides you real value if you are also able to integrate that into a bigger picture. What do I mean by bigger picture? So we are talking about a CAD/CAM workflow, but in a big enterprise you might also have like an MES system, an ERP system. Maybe you have even, let's say, futuristic systems like you're using HEVs traveling from and to the robot or whatever. And to have that holistically implemented and being able to communicate with each other, there is, let's say, it is important to be able to do so. And of course, that's possible with our solution here. And we have some very nice projects where we, let's say, implemented the one or the other to this complete full-blown process chain. Just a brief topic on the controller side. So you know the robots do not use robot controllers. They are very unique because they use CNC controllers as a solution to run the robot. Why is that so? Because of the accuracy. A robot is not, an articulated robot is not what you consider to be the most accurate kinematic system, because it's serial accesses, serial joints after each other. It has some disadvantages, but it also has some huge advantages, which is that you get a very high build space with very little mechanical effort. So this is the beauty of robots, that you do not, I always say, you only need little iron to build huge build spaces. And to overcome the disadvantages about the accuracy, we developed this Run My Robot application for our CNC controller. Basically, we told the machine that it is, it thinks it is a CNC machine. It doesn't know that it is a robot. So you program it like a CNC machine tool, and we have certain algorithms like look-ahead algorithms in the CNC controller, which come from the machine tool world, which make a typical CNC machine more accurate. And we have very robot-specific applications as well. So calibration with ESIOS, where you can calibrate your robot to be even more accurate. We have compensation cycles like CC Rocco. or secondary encoders, which is also a very exciting topic to make a robot more accurate. So you can see by that we are filling the gap between a standard robot and a very accurate machine tool. So if you look at the machine from Beat Pilotti, this is like a very massive machine, of course very precise and accurate. And to, let's say, get a robot closer to what that machine can achieve, this is basically what we do here. There are a few more things which we can, let's say, leverage. For example, if we have programmed a toolpath and we really want to squeeze the last bit out of it, there are features where you can analyze the toolpath with apps like Analyze My Workpiece Toolpath, where you really can see, okay, what actually you basically put from your robot or from a virtual replication of the robot, the trace in. So the trace means all the data which is being written down once the robot operates, and you exactly can visualize that and see, because you always have the ideal virtual world and then you have the real world, but this one is combining those two and looking really into what acceleration values can the robot actually achieve, because there are certainly limitations and so on, and you will see that, and sometimes you just see an error like the print doesn't look good and you don't know why. This is a very good analytic tool to look into where this actually could come from, because it could be just the limitations of the kinematic. And then, last but not least, Cinemeric also is heading into the future, and I just want to give you a little outlook here. Cinemeric 1 is our newest flagship, and it also comes with a virtual controller, as you can see on the right-hand side. We call it Run My Virtual Machine. So I personally experienced that in many cases, I prepare a part for 3D printing, I slice it and so on, and then I put it on the robot, and some problem I haven't thought of appears, like an error message I just hadn't in my mind. Have to go back, slice it again, and so on. And this just takes me time away, which is very valuable, which when I'm on the machine, I want to print, right? And to be able in home office to already start up my virtual NC controller and really program, let's say, and run the program and see what happens before I do that on the real machine is very valuable. And yeah, the good news is we have developed in the AMEC now a first demo kit for the virtual machine for a Flexbot system, and it works quite well already. And I think this is something, let's say, where we also can look here at, in the future to see that coming. So I said I want to give you just a very few application examples. One is, which I developed very recently, it's this perforated facade element. So when it comes to facades or to construction 3D printing, it's always the question, do I need to print the building, or do I just print something which then is manufactured traditionally? And in this case, I think it's better to actually just print the formwork. So in this case, it's a facade element. Formwork for that is being printed. The facade element is then, the concrete is then poured into that. And you can see this perforated structure, right? Of course, I did not like put in the diameter for each and every hole, but I used algorithmic modeling for that. That's a very new feature also in Siemens NX, where you can do that. And what I want to show you now is how easy it can be to basically change the design of the part, and then initially having also the design change for the mold. So here you can see on the screen the facade element is being designed. It has a structure, and you can see here now the mold already being placed on the Flexbot print setup. It has been sliced already, the raft is being prepared, the machining setup is being prepared. So let's just say I printed the first formwork already. And now, after I printed the first formwork, I now want to change the design because I need another one maybe for the panel next to it. So you can see now I use NX algorithmic modeling for just changing the designing, the driving curve. There is actually a logic behind it, which I didn't cover in this video, but just quite straightforward. And now you can see the design change directly appeared in the print setup. So I didn't have to export the new part file, maybe extrude for a new formwork again. It was directly, let's say, transferred to the new, and I can, let's say, print one formwork after the other for different one size, one part of panels. It's not a big deal, and this is what I think is the beauty of a fully integrated process chain, that I do not have to import, export, and I save a lot of time. I speed up my engineering processes here by leveraging that. And then another very short example, I do not have too much content from that one, but what you can see here is basically a car. I think some of you can estimate the brand. It's basically one of the challenges you have in the automotive industry is that once you bring up new components to the market, you need to validate them, and for this validation process, you might not have a car already ready. Yeah? So you need to validate a component like a vacuum pump, and you do not actually have the part where it needs to go in there. Yeah? So sometimes you need to fit them in a car, in an old car or whatever. So the R&D engineers, they need to have access to methodology, how they can print like some structures which allow them to implement those components into an existing car. And 3D printing obviously is the way to go here. And here, together with a colleague from, or let's say an expert, an additive expert from Technical University of Munich, and some guys from BMW, we have been developing this concept where we use the Flexbot system to come up with, let's say, a 3D printed component carrier within half a day or so. That's the goal, yeah, to really, that somebody says, I need to equip this car with that component. You just add in the parameters and then you create the component. I think there was, yeah, sorry about that. There should be a simulation, but it doesn't seem to work. But basically what we did, so the component carrier is not flat, it's not planar, but it's like shaped like that. And so we created an approach where we created, with 45-degree printing, we created some kind of supports, let's say, which we then surface finished with milling and printed on that actual support the three-dimensional structure, which we can, let's say, loosen very easily by just drilling some holes. And this made this process very, very fast. So to sum it up, there are three takeaways I would like you to take. One is that one thing that Siemens can bring to those solutions is, of course, software and automation equipment which drives machine like the AM Flexbots, which leverage them to a full potential. The other one is that these solutions can be fully integrated into a larger picture, to not have standalone islands, standalone solutions, but to have like enterprise-ready solutions. And the last takeaway is that this really can speed up your engineering processes. Yeah, so that you really are able to faster develop cool parts, not spending so much time in the engineering, but rather being quick and come up with cool parts earlier. Yeah. So let's jointly take it to a next level. Yeah. I think we should really think about applications, because that's really what is driving the industry forward. And if you're interested in any, let's say, deep dive discussions about the Siemens controller solutions, about the software, we have our booth right over there. We can also have the exchange right here, whatever you would like. And if you have any ideas about our cool applications, don't hesitate sharing them with CEAD, with Siemens, whomever. I think the more applications we have, the better for the future of large-scale additive manufacturing. Thank you very much. That's it from my side.